All right, hours of television. According to the Communications Industry Forecaster Report published by Veronis Suler-Stevenson, the average person watched 4.55 hours of television per day in 2005. A random sample of 20 people gave the following number of hours of television watched per day for the last year. And that's on a spreadsheet tab that we'll take a look at. At the 10% significance level, do the data provide sufficient evidence to conclude that the amount of television watched per day last year by the average person differed from that in 2005? All right, so the P in phantoms. So we're looking for the mean amount of TV differs from, we're looking for whatever that amount was in 2005. So that would be the 4.55 hours. So that's what we're going to write down there. The H, so our two hypotheses have a null and an alternative. And since we're looking at the mean, this is going to be mu for both of these. And the 4.55, that's going to be our null hypothesis. We'll use that same number for the alternative. And since we're looking at it differs, that's going to be a not equal to. So this is a two-tail test. And then let's write down our three assumptions and conditions. So I have simple random sample, normal large, and then sigma. Okay, so we have a random sample here, so we can check that off. So that'll allow us our statistical inference to apply our results to our larger population. Our sample size here is 20, so that's not quite large enough. So we need to make a note that we need to check on that normal probability plot. We'll do that and when we get to the data set. And then there is no population standard deviation here, so no sigma. So that means we're going to need to find our sample standard deviation S. And then while we're there, we'll find X bar as well. Circle those guys. So since we do not have a population standard deviation, so no sigma, that tells us that we're doing a T as in tiger distribution. So this is a one mean T test. And then we are ready to go to our spreadsheet to get our test statistic. So let's go do that. All right, well, that was my bad. We have a couple things we have to do first before we can go over and get that test statistic. So we need to find X bar and our standard deviation. So our mean X bar from our sample. So we'll do equals the average, and I'll highlight these TV hours. And then our standard deviation S from our sample. I'll do equals STDEV and highlight those guys. I'm going to write both of those down. So I have 4.8 for X bar. And for S, I have let's call it 2.297. And then we have one last thing to check here. We need to look at that normal probability plot. So to do that, I'm going to click on my data tab. And then all the way over on the right is my data analysis. And then remember that everything we've done on that data analysis tab is under this regression menu item. So anything as you're preparing for the final, anything that we did off of that data analysis is in that regression spot. All right, so my Y range is those TV hours. My X range is going to be that first column. Then I'm going to click this box that says normal probability plot and say OK. So here's our normal probability plot. It's definitely got some bumps in it, that's for sure. It's not the most straight of lines, but with a larger sample size of 20, which is getting closer to the 30, and it's not terribly bad. I suspect that we could fit a pretty straight line across here, and there would be some that are going to be a little bit over and some that are going to be a little bit under. So I'm going to call this close enough. So I'll circle normal on my paper and put MPP straight enough. If it wasn't, there are some other statistical techniques we can use instead of a t-test, and that would be something you would look at in a more advanced class. All right, so now we are ready to go look and find our test statistic and get our p-value. So let me switch over to that screen. All right, so now we're ready to find our test statistic and our p-value. Just always remember to check these tabs at the bottom to make sure you're on the one that matches what you wrote down for the name of the thing you're doing. So we're doing a one-mean t-test. It's out of chapter 20, so I'm on the tab that says t-test. All right, so x bar was 4.8. Mu, which comes from my null hypothesis, was 4.55. My standard deviation is 2.297. My sample size here was 20. And then degrees of freedom is sample size minus 1. So that makes this 19. And that gives me a test statistic of 0.486. One down 3 decimal places there. And then my p-value, so this was a two-tailed test. So my p-value is 0.63. All right, and then we're ready to head back to our classwork to finish this up. All right, so here's our p-value and our alpha. So they told us we're at the 10% significance level. So my alpha is 0.10. Okay, so p here is definitely bigger than alpha. So that means my decision here is do not reject the null. Okay, so I do not have enough evidence to disprove the null hypothesis. Okay, so my conclusion statement here is with p equal to 0.63 at the 10% significance level, we do not have sufficient evidence that the mean amount of TV watched differs from 4.55 hours. All right, and there is your conclusion.